Well, guys, we'll go ahead and get started then. Those of you guys that were here on the last one, we had talked about the beginning of the universe, how we know that the beginning is actually exactly what Scripture says. This time we're going to go deeper into that. We're going to look at the fine-tuning of the universe. I had said it last time that this is one of my absolute favorite parts of apologetics, is the fine-tuning of the universe. We won't be going into how old the universe is. That's a curiosity point that you can research on your own. What really matters is if God made it, not when God made it. But another quick thing is, I thought about this last time after we had talked about that we're going to be talking about the fine-tuning this week, is a lot of you guys might not really realize where the term fine-tuning comes from. See, like when Brad and I were younger, our TVs weren't all digital. So what you would have to do is you would click it to the nearest channel, and then you would take another little dial and you would move it back and forth, move it back and forth, move the antennas, move it back and forth until you got everything tuned in just perfectly. Okay? And this term, the fine-tuning of the universe, that's where it comes from, is these parameters are all so tight. Everything is built upon it. A lot of people call it upon a razor's edge. So if you think about that, think about a razor blade, standing it on edge, and then stacking things on top of it. Take an egg, a shoe, a small dog, whatever the case may be, and stack them up on top of this razor's edge. What is it going to take to get those to stay exactly in place? Everything has to be exactly right in order for those to stay stacked up. Otherwise, it's all going to come tumbling down. And once you start looking at how much is built up onto this, you start realizing that the only way that this works is if there is a governing force holding it in place. And that's what we'll be talking about today. One other quick thing is we will be using some exponents. We won't be going into math or anything, but in case it's been a while and you've forgotten about exponents, or if you haven't learned them yet, exponents are actually very easy. If I say, your chances are 1 in 10 to the 4, the 10 to the 4 is simply a 1 with 4 zeros behind it. Okay, so if I say 1 in 10 to the 4, that'll be you have one chance, and it would actually be 10,000, right? But the numbers are going to be a lot bigger than that. It just gives you an idea of what we're dealing with. So the number that comes after the 10, that's how many zeros are behind that number. Make sense? Okay. So when we had talked last time, we had said that we had talked about the beginning of the universe, and we had looked a little bit at Genesis, what it actually says. This is a verse that everybody knows, right? Christian, not Christian, whatever the case may be. But in the beginning, God created the heavens and the earth. But we see it much further as we go deeper. Thus says the Lord, I have not established my covenant without a day and night fixed order of the heavens and the earth. So when we start seeing things like the fixed order, and here in Psalms, of old you laid the foundations of the earth, and the heavens are the work of his hands. We're talking about the fixed and the foundations. We're not talking about the earth sitting on a cement foundation here. We're talking about the parameters that are needed to be in place in order for things to be functioning. We're talking about laws of physics. We're talking about natural forces, things like that. But this verse, we know, most of us Christians know this pretty well, right? For I am persuaded that neither death, nor life, nor angels, nor principalities, nor powers, nor the things present, nor the things to come, nor the height, nor the depth, nor any other creature shall be able to separate us from the love of God, which is in Christ Jesus our Lord. When we look at this and compare it to the other verses that we just showed, just keep this in mind, because it's saying that there isn't a darn thing that comes between you and God. So even when we're talking about the laws of physics and the science that holds stars together, holds planets in place, keeps them all in order, not even things like that can keep you away from God. Not these strong forces that we're talking about. I just find that very encouraging. But last time we had talked about this, right? The cosmological argument, it's actually very simple, right? Whatever begins to exist has a cause. If the universe began to exist, we showed that last time, therefore the universe has a cause. And I had said by the time we got done with last week's and this week's, we would be able to show that a theistic creator is the only one that can answer the question. But this time we're going to be talking about the teleological argument. Another very simple one, right? Every design has a designer. The universe has a highly complex design, therefore the universe has a designer. I hope as we go you will see exactly what we mean here with the design. It's undeniable once you start seeing everything come together. Now, a couple of you guys were in when we had done the class back in April about the fine-tuning. We're going to go deeper than we did in April. We have more time now. But when we had talked about it in April, I had said that if we take something and we look at a robot and we see the complexity, we would never for a second think that it was laws of nature that were responsible for that robot coming into being, right? That there had to be an intelligent mind behind it. Even if we go all the way down to a little paper clip, a simple paper clip, if we find it laying on the ground, we would never for a moment think that there wasn't a person behind that paper clip at some point. Somebody that made the machine that made it happen. Somebody that programmed the machine that made it happen. We would never for a moment think that it was by natural forces, by accident, by anything like that. But since we're going to be talking about everything out in the cosmos today, I thought we would use this as an example, right? This is the Atlantis. This is what NASA considers to be their workhorse space shuttle. It actually flew 33 missions. The thing weighs 69 tons. We're not talking the engines, we're just talking the shuttle, 69 tons. And to give you an idea how long it is, just the shuttle, you guys have all been on a football field from the end zone just about to the 40-yard line is how long that is. Ended up costing $196 million. Took 4 years to put it together. We're not talking the design and engineering phase, just talking about putting it together. But you see complexity after complexity, many layers of complexity. Once again, you see something like this, you know that there's a designer behind it. So as we go forward, I want you to keep something in mind, keep an analogy in mind. Think about if we have an explorer. Now, Gracie and I took and did this. We took Bear Grylls' body and put Mr. Bean's face on it. But think about an explorer being lost in the wilderness, right? He goes out for a walk, goes out exploring, gets lost. He's out there for 3 days. Paranoia is setting in, especially since he's got diabetes. He needs his insulin. Storms are moving in. Things are getting pretty scary for him. Giving up all hope, he decides only thing he can do at this point is close his eyes, walk for 5 minutes, and hope, just hope with everything he has in him, that when he opens his eyes, there is something there to give him protection. So that's what he does. He closes his eyes, walks, opens them up, and what does he see? But a little cabin in the woods. Already you start thinking there's no way that this really happened, right? But what about if we go further and we say, well, the door was locked? And this explorer is a lot like me who likes old things. I love looking at the craftsmanship of things that were built long ago. And let's say that he found a key several years ago at an antique shop, an old skeleton key. He had put it on his keychain, put it in his pocket. Out of desperation, he decides to try it. He puts that key in the door and click, it opens up. We would think that there's only one of a couple things going on here. The person that's telling the story is either making it up like I am, right? Lying about it, saying that it happened for real, or that there is something bigger going on here. That there is some other force over this, whether he's being punked, whatever the case may be, there's something else going on, and this isn't actually the case, that these would be happening by chance, right? But the reason why I use this as an analogy is because let's think about Earth. What do we need? We need a place that is very suitable for us for protection. We need a place where we can get into safety and get out of elements that can destroy our planet. Now, last time we had talked about how we know that the universe had a beginning. Well, in order for us to have a place in the universe, obviously we have to have a universe. But what does it take for when God created the universe? What does it take to get that into place? How much fine-tuning is there just in the very first moments of the universe? So you have to remember that when we look into our telescopes, we're actually seeing back in time. Since it takes time for light to get here, when we look at far distances, we're looking back in time. So when we turn around and we look into the past, we can actually see within the first few milliseconds of the universe. And we see that there is an expansion rate. Remember, we had talked about that last time, that the universe, the expansion rate at which it came into being, and that is very fine-tuned. But when we're talking about the expansion rate, one thing I want you to understand is how big the universe is. Numbers of stars in the universe. That's a lot of stars, isn't it? Now in April, I had told you guys about Simon Driver, the astronomer, and what he did was, after looking at the estimation for the number of stars, he started getting curious, right? You go and you look in Scripture and you see two promises from Abraham, don't you? Or to Abraham. You see one, that he will have descendants as numerous as the stars, and what's the other one? Numerous as grains of sand. So he takes and he estimates how many grains of sand are on all the beaches and all the deserts on the face of the earth. What he actually determined was that there is more stars in the sky than there is grains of sand on the face of the earth. To give you a little bit of an idea on how many stars we're actually talking. But because of this, because of the size, because this number of stars, the number of galaxies, and just in the Milky Way, people like Stephen Hawking has said this alone shows that God isn't the answer. Because there's so much waste going on. There's so much extra that isn't needed. But is that the case? He had said this many years ago, before we've made a lot of the discoveries now. But even just looking at it from a philosophical standpoint, is that true? Is the size of the universe a waste? If God is using it to show how big and how powerful He is, I don't think that's a waste. But what about when we look at the science? See, one thing that we end up finding is the mass of the universe and everything inside it is very, very crucial. And if this is one of those fine-tuning parameters where if we were to waver the density of the universe one way or another, we end up not having a universe. Just the density of the universe itself. I don't know if you guys have looked at what it takes for nuclear fusion to happen, but through nuclear fusion is where we end up getting all of our elements, okay? And if you have a universe that is smaller, what ends up happening is all of your elements then end up being to the point where there is nothing heavier than carbon. If we go bigger, we end up with elements that are only about iron or above. It's just in this very fine middle area that we have all the elements that we need to survive. So already just the density of the universe plays a very big role, but also the expansion rate of the universe. So if the universe would have expanded faster, what would have ended up happening is as it expands, as everything is going out, if it's going faster, gravity could not grab a hold of the elements in order to pull them together to make the stars and to make the planets. If it would have went slower, though, it would have collapsed back upon itself. And Mr. Stephen Hawking, after going through and seeing all of this through many years of research, along with a lot of other people, obviously, he's calculated it down to being if the rate was affected by about 1/1,000,000th. So what does that look like? The rate of the universe affected by 1/1,000,000th. And they actually calculate it out to be very close to, if it's wavered one way or the other, by a picosecond. I'm sure most of you guys don't know what a picosecond is, though. What a picosecond is, if you were to hold up a hair, a human hair, and a picosecond is the amount of time something traveling at the speed of light passes one side of the hair to the other side of the hair. So this is an insane amount of fine tuning. If you were to waver the expansion of the universe by that much, one side or the other, you don't have a universe. And keep in mind who is calculating this. You have Stephen Hawking, who is a devout atheist. A lot of his coworkers are devout atheists that are saying this level of fine tuning is just insane. But there's another thing going on here too. So we're talking about the density of the universe, but yet we're talking about the universe expanding, aren't we? So I don't want you to mistake this, because when we're talking about it expanding, we're not talking about more stuff being put into it. What we're talking about is everything is spreading out further, okay? So think of it this way. If you were to take a balloon and just looking at the surface of it, put some black dots on it and then blow it up, what's going to happen to those dots? They're going to start moving further apart from each other, right? Well, that's what's going on with the universe. They're moving further apart. There isn't more stuff being added. They're just moving further apart. But what makes this happen? And this was a big mystery for many years. It wasn't until, I don't know if it was 98 or 99, they started realizing what's going on, and they actually named it dark energy. This isn't like a spiritual darkness. Think of it more like an anti-elastic band, right? How does an elastic band work if you start pulling on it? The further you pull it, the harder it gets to pull. This works exactly the opposite. The further apart it goes, the more it accelerates, the easier it gets. So this is why when we look at the universe, we see it accelerating faster now than it has in the past. And we see that through the telescopes, but remember, we also looked at it last time, and we saw that even in Scripture, we see them talking about the universe is still expanding. Excuse me. But all this talk about gravity and expansion, I do want to hit on one thing that ends up coming up quite a bit when you start talking about this. Once again, Stephen Hawking, he has turned around and he had said that with the universe, with the laws such as gravity, with the law of gravity, the universe can and will create itself. Does that seem to make sense, though? First off, think of this. He is saying before the universe ever existed, before the universe ever was, there was gravity. That seems to be a problem already, doesn't it? But next is, can the law of gravity have anything to do with creating something? We have gravity going on all around us. Do we see popping into creation now? Of course not. See, the laws of gravity, any law, only works when it's able to govern over something. It doesn't work on its own. It can't create their own things. Minnesota, we have our own speed limits, right? It's the law of Minnesota to drive whatever the speed limit is at whichever road you're on. Some of you guys may drive a little faster than that with the smiles on your face, but... But does that speed limit in Minnesota carry any weight in California? Of course not, right? Why? Because that law is not able to govern over anything in California. Well, the same thing is going on here. If we're talking about, even if gravity were to have existed before the universe, it can't do anything. It can't govern over anything to begin with. This topic brings up two of my favorite quotes from one of my favorite apologists, and it's John Lennox. And he says this. He said, "What all this goes to show is that nonsense remains nonsense even when talked by world-famous scientists." So even if somebody as intelligent as Stephen Hawking says something that is ludicrous, it remains ludicrous, right? But this next one, to presuppose the existence of the universe to account for its own existence, sounds like something out of Alice in Wonderland, and not science. He's saying what we were talking about a minute ago. To turn around and say that part of the universe existed before the universe existed, and that's what helped create the universe. is more something out of science fiction than actual science. But so now we finally have our universe. Does that mean everything is easy going from now on? And it certainly doesn't. First off, there's only 3 types of galaxies, okay? We have our solar system, which is in a galaxy, which is in the universe, right? But you can kind of think of the different types of galaxies sort of like different neighborhoods, okay? So first is the elliptical galaxy. Life cannot exist in the elliptical galaxy for many reasons. One is as it's too crowded, there's too much deadly radiation, and there's no consistency going on. Excuse me. And the crowding that is in there makes orbiting impossible. Okay? So when you start, and the other thing is there's not enough of the necessary materials to support life anyways, enough of the right elements to support life. So you can almost think of this more along the lines of an old rundown neighborhood, right? It's rundown. A lot of the stars in here are old. And what actually ends up happening is because of the way the galaxies are, the stars that are in those galaxies, what ends up happening is they come, when they're created, they end up getting really bright and going out really quick. So we have got rundown things without the ability to fix them up because we don't have the elements to make it work anyways, to make it into a habitable galaxy. The next one is an irregular galaxy. Okay? These we can't support life because there is no consistency inside an irregular galaxy. That's why they gave it that name to begin with. You see constant clustering crashing into each other. There is no orbiting going on, and they are filled with deadly radiation, which leaves us with the spiral. Spiral galaxy, this is what ours is. So you might be thinking, well, fine, you took 2 of them out. Does that mean there's about a third left? No. Spiral galaxies only account for about 5% of the galaxies that are out there. But just having a spiral galaxy doesn't get us so that we have life. We have to have a spiral galaxy in the right place. We have to have the right neighborhood around it. See, if we get around a supergiant galaxy, it's just a name for a really large galaxy, which floors me because all the really cool names that they use in astronomy, they can't come up with a cooler name than a supergiant galaxy. But anyway, a supergiant galaxy is, they estimate it to be about 10 to 1,000 times the size of the Milky Way, just so you have an idea of a supergiant galaxy. But we can't be around one of them. And the reason is because, number one, with one that large, they end up drawing other galaxies into them. Think about the consistency that we need. We can literally set our watches by our days. We can literally set our calendars by the rotation around the sun. We need this consistency, and we'll get into a little bit more later why. But so if we were to get pulled into a giant galaxy, that would throw all of that off kilter, wouldn't it? But the other thing that ends up happening is supergiant galaxies, they take and they draw the gases out of the galaxies around them. Okay, this is called ram pressure stripping. Okay, so we need to make sure we're not by any supergiant galaxies, which if you look at where we are, there's only 2 larger galaxies. There's us and the Andromeda galaxy. Those are the only large ones around. And the Andromeda is, relatively about the same size of us, and it's far enough away where it's not a problem. So we can't be around supergiant galaxies. We can't be in clusters. We can't be on the outskirts of the universe either because there's not the elements needed, once again, to support life. So even once we get to the point where we have our galaxy in the right neighborhood with the right surroundings, we still have a lot of fine-tuning to go. One thing is we need to be able to have dwarf galaxies around us. This is one of those areas where the golden rule doesn't apply. Remember how I said we can't be around supergiant galaxies because they'll draw the gases out? We need to have dwarf galaxies around us to do exactly that. We need to be able to be pulling gases from something else in order to help keep us going. So we start drawing the gases from dwarf galaxies into our galaxy in order to help keep us alive. But the amount is very crucial here once again. If we don't get enough gas, we end up collapsing. If we get too much gas, we end up with a warp or a bulge. So if you look at this, you see it almost like a fan, right, going around. If we get a bulge, it ends up throwing everything off kilter, and it sets the stage for destruction. Okay? And the size of our galaxy is very crucial. See, if we were a large galaxy, we would be doing exactly what the supergiants are doing, and they're pulling galaxies into it. So imagine all of a sudden if there's more solar systems being pulled in next to ours, imagine the problems that that's going to cause. But if we're too small, we can't survive either. And the reason why that is because even once we have our galaxy that we need, it's fine-tuned inside of here as well. See, if we're a smaller galaxy, everything is compressed too much, so you end up with the collisions, you end up with solar systems passing and mashing in together. But our solar system, hold on, here's the three of them together, okay? Here is a supergiant galaxy, so you can see kind of the difference going on here. And then there's this slide. So this is what ours is, okay? We are right in here, okay? This is very crucial because if we were to the outskirts more, we would not have the elements needed to survive. If we were in more, we would be getting the deadly radiation from the core. So we need to be in the middle, but we need to be in the exact middle, not just in here somewhere, because there's what's called co-rotation. And what that is as the universe is going around and as we are going around, we need to be in the right place so our rotation matches its rotation. That way these arms that are coming out, we don't get hit by them. See, if we touch the arms, we won't survive. The solar system is destroyed if it gets touched by the arms. So we're seeing some fine-tuning here too, aren't we? And this, all we've done so far is get a galaxy and get our place inside the galaxy. Just a second here. But with all this that we're talking about, with the density of everything involved here, we're talking about all the different galaxies. We're talking about the placement in the galaxies. When we start talking about everything that's inside of it, and we start talking about this density rate, if we were to affect this density rate one way or the other, more or less, we can't survive. The universe itself can't survive. So how much are we really talking, wavering? If we were to say that our universe is this ship, this is the USS Stennis, okay? If this was needed to be as fine-tuned as our universe to stay afloat, it would mean that if we added to it or took weight away from it, it wouldn't survive, it would sink, right? So what type of fine-tuning are we talking here? Are we saying that if we add to or take away somebody my size, 200 pounds on this whole ship and it would sink if you added to it or took that amount away? That alone would be some pretty amazing fine-tuning, wouldn't it? But what it actually is so much less, okay? What it actually comes down to being is an estimated billionth of a trillionth of the mass of an electron. If you were to waver it by that much. So what the heck does that look like? To give you an idea, remember electrons are inside your cells. This is about how many cells are inside a 154-pound adult. And if you are taking a sliver of one of these cells and affecting it by a billionth of a trillionth, that ship would sink. That's the level of fine-tuning that we're talking about with the universe here. Okay, so you're starting to see some pretty insane parameters, aren't you? But like I said, so far all we have is we have our universe and a galaxy in the right place, and our solar system in place. So if we go back to the explorer, right? Now what would happen if I say now that he's inside, he goes into the bathroom, and what does he find? But he finds the insulin on the shelf in the bathroom that he needs to stay alive. He had broke his glasses. The glasses with the same prescription are sitting there as well. He goes into the bedroom and he finds clothes that are the same size as what he wears. When we start seeing all these things start to pile up, we start saying there's no way that this is going on unless there is somebody involved in this, don't we? But back to the universe, we now have a home for our solar system, right? Now, just the Milky Way, remember there's right around 300 billion stars. This obviously is one of them. This is ours. Our star is very fine-tuned for us. If it was any bigger or any smaller, it wouldn't be putting off the right materials, the right elements for us to stay alive. But I want you to get a grasp of the size, okay? So this is a solar storm that's going on right here. What ends up happening after that is that's where we get our solar flares and stuff from, right? But this coronal mass ejection is what it's called. This was in 2014. It's the largest one that they have record of. This little spot right here is 7 Earths wide and 5 Earths high, to give you an idea of the size of our sun. That's insane, isn't it? But if it didn't put off the right elements or the right type of light, we wouldn't be able to have life on our planet. That's not all that we need, though, for surviving. We also need, oh, there we go. There's a close-up of it. I forgot I had that in there. We also need Jupiter, though, okay? A lot of people end up thinking that we have our sun and we have the Earth, and the other things are just kind of cool to look at. That's not the case, especially when you start looking at things like Jupiter. Jupiter's size alone is phenomenal. It ends up being 588 billion miles from Earth. It takes 40 minutes for the light to get here. But you can actually fit 1,321 Earths inside of Jupiter. Okay? Jupiter's role, one of its main roles, is it's our bodyguard. Okay? A lot of people end up calling it the cosmic vacuum cleaner because it is so big. Its mass and its gravitational pull either draws in comets, asteroids, space debris into it or deflects it away. And this is important because if this is Earth and this is Jupiter, we travel in line with each other. So Jupiter is always there as our bodyguard. Okay? Why is this so important? It's because things like this. Okay? This is images from immediately after what's called the Comaker-Shoemaker levy. Now what this was they had been watching this comet circle Jupiter for about 25 years. And in 1992, they watched it break apart into 21 pieces. These 21 pieces were about the size of Manhattan Island, each piece, which is right around 23 square miles. But what ended up happening then later, 2 years later, is these started crashing into Jupiter, going about 154,000 miles an hour. They figured the explosions would have been about 10,000 miles high. This is what Jupiter does, time after time after time again. It takes impacts so that we don't. Imagine what that would have done to Earth. Even just one of those, let alone 21 of them, Okay, and here you see the bruises from it, right, all over the place. These are bruises in the atmosphere. They're not, we can't actually see through the atmosphere into Jupiter, which is very common for planets, not being able to see through to the planet itself. Okay. 15 years later to the day is the Wesley impact, though. The Wesley impact, what ended up happening is as Jupiter, orbits and comes back around, they see this big bruise on it. Something hit it when it was towards the far side from us. The thing is this tiny little bruise down here is bigger than the Pacific Ocean. Tiny little one down here. So you can once again see what the heck is going to happen if that hits us. Another interesting, here we go. Right around in here, if you go and look at images online, watching Jupiter moving, I was going to have it, but for some reason I can't get the internet to go. But you can actually watch a hurricane spinning on Jupiter. It looks kind of cool. But Jupiter's size is something that we don't see in other solar systems in the location that Jupiter is. See, you never see a planet as large as Jupiter in as far in a solar system as it is in ours. Because what ends up happening is the gravitational pull between Jupiter and the sun, they'll end up pulling each other in. Okay? So why does it work here? It works because we don't only have Jupiter, do we? We've got Saturn and Neptune and Uranus, which we all hate to say in church, but we've got them behind it. And especially when you look at Saturn, Saturn's job, one of its main jobs, is to take and hold Jupiter in place. They all work like this, holding them in place. But Saturn holds Jupiter in place to the point that Jupiter actually goes within about a 2% of a perfect rotation. It's that precision that keeps it in line with us, okay? But when we think about Saturn, what do we normally think of? We think about those rings, right? Now, Saturn is another huge planet. You can fit right around 1,000 Earths inside of Saturn. Jupiter is about 2.5 times the size of all planets combined in the Milky Way. Or in our solar system, in our solar system. But when we talk about Saturn, the rings alone, what we commonly know it for, and just so you know, Saturn isn't the only one that has rings. A lot of the outer planets have rings. They're just not as well pronounced as Saturn's. Okay, but the Saturn, from the rings from the inside to the outside, and these are lettered, that's how they name them, is by letters, but from the inside to the outside is actually 175,000 miles. So what does that look like in compared to Earth? You could actually stack up 7 Earths in here to get to the outside. But the thing I find coolest about these rings is the thickness. So 7 Earths wide, but thickness, they range between 30 feet, so a little bit longer than this room, to 300 feet. They're very thin. Length of a football field is the thickest that they are. So if you were to take and build a scale model of Saturn, and if you were to make Saturn so it's about 3 feet, round, the rings, if you were to make them accurately sized, they would have to be about 1/10,000th of the thickness of a human hair. That's how thin they are. It's things like this where we're not only seeing the fine tuning, but we're seeing the amazement when we actually look out. Like I had said though, we've looked at Jupiter, we've looked at Saturn, Uranus and Neptune. You take and you put the 4 of those together and they act like a wall so that things don't get through to us. So that we don't get hit by things flying around, okay? We're finally we're finally honing in on Earth. We can't really talk about Earth, though, without talking about the moon. Okay? This is another thing that you do not see. You do not see planets our size with moons that size. Our moon is huge. Our moon's purpose is much, much more than just looking cool and lighting the path at night so we can walk without flashlights. Okay? It keeps us on a perfect tilt. See, the axis that we're at is 23.5 degrees. And if we vary from 23.5 degrees, we don't survive because it affects our temperatures way too much. But it does a lot more than just hold us at our axis. And one thing, since we're talking about the axis, they actually figure if you would vary the size of the moon by about 2%, that would be enough to destroy us. 2% the size of the moon you were to change, plus or minus, it wouldn't be able to hold us in place. If you add to it too much, it's going to pull us off our axis. So we already see that fine level there. But so what are the things that the moon does? Well, the moon is responsible for the atmosphere that we have because it's pulling elements up into the atmosphere that help give us the protection that we need. So it gives us our atmosphere, it obviously gives us our temperatures, but it also gives us our waves, right? Our waves are responsible for many things, a lot more than just surfing, right? But so it not only moves around the nutrients in the ocean so that our ocean life can stay alive, but where is the heat always hitting on Earth? It's always hitting around the equator. That's the hottest part, right? What ends up happening because of our waves is it distributes the temperatures throughout the oceans. So yes, it gets colder as we get to the poles, but it's keeping the water temperatures moving enough so that we have enough ocean so that we can have the ocean life needed, so that we can have our rain cycles, so that we can have life on Earth. Now, a very interesting thing is last year they started doing an experiment on the International Space Station. What they started doing is they started trying to grow plants on there. And it was to see what would happen, because think about it, we have the International Space Station, which is flying around. Sometimes it's close to the moon, sometimes it's far away from the moon. So what are the effects that we see? They actually call them leaf tides now. Where we are in relation to the moon affects how plants can live. What they're finding is the gravitational force from the moon helps the water travel through the leaves into the plant. Otherwise, if we didn't have the moon sitting there, we would have no vegetation on Earth. It's little things like this that really start putting things into perspective. But so now we're at Earth. Does that mean that the fine-tuning is done? This is where the fine-tuning just starts. We're not going to go through all of it, obviously, but what have we been talking about the whole time that is needed so that we can have life on Earth, right? So what is the life on Earth? We can categorize it basically into 3 categories, okay? We can have just physical life, which that's going to be, your fungus, your bacteria, things like that. Now you can have things with a physical life and a brain. That is going to be your animals, okay? And then you can have physical life with a brain and a mind, or a spiritual side, whichever you want to call it. So where you can ponder things like why we're here, the purpose of life, all that stuff. Those are the 3 types of life. So when you think about what is needed for Earth to live, think about that wide variety that is there that needs to be provided for life to survive. It would be a lot easier if we only had to have elements so that humans could survive, or only had to have elements so frogs could survive. Whatever the case may be, it would be a lot easier. But when you have this huge wide array, it gets quite a bit more difficult. Just to give you an idea on how much life we're actually talking about, with the species, there's right around 6.5 million species on land. About 2.2 to 2.3 million species in the water. And with the water especially, we only know a fraction of what's there, okay? And these numbers, these 8.6, 8.7, right around in there, this does not include any of that first type of life where it's just a physical life. Just to give you an idea on how much life we're talking about. You good? Yeah. Now, Carl Sagan. I don't know if any of you guys are familiar with Carl Sagan. That the big Cosmos TV show that was on, I don't remember if it was last year or the year before. He was actually one of the creators behind that. But in one of his books that he had written years ago, he had talked about Earth. And even so, we have all the life on here that we were just talking about. He had said this. He had said, imagine that there is an astronaut that's in the space shuttle and he is leaving. He has gotten far enough to the point where he looks back and all he sees is a pale blue planet. Then he said, now he looks forward and he sees the vastness of everything that he's heading to. He had said that because of this alone, the significance and the meaning of Earth is minimal, if anything. He said that Earth itself may be meaningful to us, but it's meaningless to the universe. Is that the case, though? Because we just see the size, does that determine meaning? Does that determine anything other than size? It doesn't, does it? And I'm saying this for one important reason, and that's because I don't know if it'll be the next class or the class after this. After that, I want to talk about the subject of abortion. That is something that you guys are having to deal with now more than ever. So what does that mean? When we look at it, what is life? When does it begin? And what should we be doing with it? Is it meaningless because of its size? Like Carl Sagan says about the Earth. We'll be looking into that. And how do you use that when you go outside of the doors of the church? Okay? But back to this. Sorry, I got a little bit off subject there. But like I said, now we're finally at Earth. What is needed for all of these lives that we're talking about on Earth, right? The 6.5 million species on the land, the 2.2 to 2.3 million species in the water. What is needed? Well, we know that we need gravity, right? We had talked about why gravity is important for the plants, but we need it so we don't go floating away along with many other things. So what happens if we adjust the level of gravity on Earth? Is that going to affect us, or is that fine-tuned as well? They actually calculate that if you would change the gravitational constant by plus or minus 10 to the 60, that the universe would no longer exist. What does that look like? Remember, we're talking about 1 in 1 with 60 zeros behind it. So what does that look like? When we get this big, even analogies don't really help very much. But what this looks like is if you were to take a 1 inch by 1 inch target and shoot at it, what level of precision do you need to hit it? Right? If we say 1,000 yards away, you need some definite precision, right? If I said we set it in our yard in Springfield, how much precision would you need? A lot more, okay? What happens if we set it on the moon? How much precision would you need?
A little bit.
A little bit. The thing is to get the 10 to the 60, you would actually have to set that target at the edge of the known universe and shoot at it from Earth. And think about this, just so you get an idea on how far that is. If you were to shoot that bullet from Earth, you know how long it would take traveling at the speed of a standard bullet? How long does it take just for that bullet to reach the moon? It takes over 3 days. But we're talking about the edge of the known universe. Think about that level of precision that would be needed for that bullet to get there and hit a 1 inch by 1 inch target. It's hard to comprehend, isn't it? But is that all that's needed? Is that all that's needed is gravity for us to survive? Well, absolutely not. Right? We need oxygen. So let's look at oxygen. If we were to adjust the level of oxygen, what happens? Our oxygen level is at 21%. If you drop it lower, if you were to drop it all the way down to 15%, there wouldn't be a living thing on the face of the earth. It'd all suffocate. What happens if you bump it up? Bump it all the way up to 25, there isn't a living thing on the face of the earth because everything just spontaneously combusted and burst into flames. So our oxygen level is fine-tuned. What about the Earth's rotation, though? Right? 24 hours in a day. What would happen if we would adjust that? We end up with a runaway temperature if we go one side or the other. Think about how much warmer it gets during the middle of the day and how much cooler it gets during the middle of the night. You adjust the length of the day, you start adjusting those temperatures. You make the day longer, and now all of a sudden you have such significant changes in temperatures that life can't exist. You make it shorter, you have the same thing, but you also start really having problems with the atmospheric winds. They would end up being to where we couldn't survive. And these are just a couple things that are involved with this subject. What about the Earth's crust? If we go thicker, we can't get oxygen transference. If we go thinner, we don't have stable tectonic plates or volcanic plates. So Earth's crust is fine-tuned. Not nearly as much as everything else that we're talking about. What about the strong nuclear force and the electromagnetic force? Some of you guys have learned about these by now, right? The four main forces, this is two of them. The ratio between them, though, is what we're looking at here. They say if you were to affect the ratio between them by about 1 in 10 to 37, that there wouldn't be anything that would stay together on the face of the earth. What the heck does that look like? Another analogy to help you, but it's still hard to comprehend. If you were to take and cover this room with dimes, and you were to paint one dime red, and I were to blindfold you until you have one shot to go and find this one dime and pick it up. Not real good odds that you're going to get it, right? This is more along the lines, though, if you were to cover North America with dimes. Except for it's not one layer thick. It's about here literally to the moon times just about 1 million. What are your chances of grabbing that one dime that is now colored red? See, these are the things that we end up talking about. You see why we call them fine-tuning. It is such a razor's edge. It's such a fine parameter where if you adjust it one way or the other, we don't have life. We've talked about 10 to the 60, 10 to the 37, different numbers like that. This next one, though, I don't have an analogy because I can't comprehend the number at all. And where exactly is it? Oh, there we go. The mass and energy ratio. If you were to adjust that by 10 to 10 to 123, that's something we can't even think, can we? 10 to 10, so take 10 times 10 times 10, 10 times itself, times itself, times itself, right? All the way up until you get now to the 123. And now you take that number and exponent 123 times. You can't comprehend it, can you? There is, I don't remember, is it 10 to the 47? I don't remember for sure right now. That's how many atoms are in the known universe. So now we start talking these numbers here. Don't quote me on that. I'll have to look it up. I should have looked it up before. It just now dawned on me. But it's right around in that area. Okay. But we're talking 10 times 10 to the 100, 10 to the power of 10 to the power of 123. These are things we can't even comprehend, right? I know I certainly can't. There's a lot of other things that we need to look at, right? What about if ice did not float, right? Water freezes, it expands, it allows it to float. If ice didn't float, we wouldn't live. Why is that? You go down in the water, what happens? It gets colder and colder and colder, right? Now imagine that the ice would sink. Now it's going to get colder and colder and colder until all you have is basically a giant block of ice. If ice didn't float, we wouldn't exist. And this isn't even along the lines of the fine tuning, it's just kind of cool things. What about lightning? Did you realize if we had more lightning, we would have spontaneous combustion because it would be a continuous cycle? If we had less lightning, though, what would happen? We wouldn't have nitrogen in the soil, so nothing would be growing. Whenever we get a lightning storm, go out and look at the grass and look at the trees afterwards. You will see that they are a lot greener and they grow a lot quicker. The lightning storm gives the nitrogen in the ground, it gives it that extra burst. But this is very crucial for life. This is only a tiny fraction of what's actually out there, right? We're talking about the anthropic constants. These are the things that can't be moved. There's well over 100 of them. Parameters, there's over 322. And the characteristics needed for life, there's over 800. There's just about 850. This is why I say that it's like setting it on a razor's edge. If we were just talking about one parameter, that would be one thing. But when we start talking about parameter after parameter after parameter after parameter, and we start seeing this very intricate design laid out, why is there ever a design? Do you ever design something for no purpose at all? No. That's the thing about the teleological argument. Remember, that's one of the first ones I showed was the teleological argument. That is showing design for a purpose. So what is the purpose? Well, obviously it's so we can have life here. If we look at our Creator, though, remember in the beginning, I had said that by the time we got done with the last class and this class, we would be able to show that the only answer is a theistic creator. The only answer is a personal God. So that means that the only one that works is Judaism, Christianity, and Islam. We'll go further and we'll show that Christianity is the answer here. Beyond a reasonable doubt, we can know that Christianity is what's true. But when we start looking at this, why do I say that? How do I say a theistic creator is the only answer? Well, let's look at creation. We're talking about space, matter, and time. Whatever created space, matter, and time cannot be part of space, matter, and time. You would never accept it if I said I gave birth to myself, would you? No. Well, we can't say that the universe is part of creating itself either. So whatever created the universe cannot be part of space, matter, and time. It has to be spaceless, timeless, and immaterial. What else, though? We know that whatever created the universe has to be powerful. To create something out of nothing takes an insane amount of power. Okay? What about intelligence? When we see all of these things that we've talked about today, and like I said, that's only a fraction of what's there, we see some intelligence to get all of these almost like gears to interlock just perfectly. What about personal? Do you think this, even if we say it's a creator, do you think that he accidentally did this, or do you think this is a willful decision? When you look at all these layers of precision after precision, you know God wasn't just up there and accidentally tipped over a bucket of universe that spilt out. This is a very precise, fine-tuned universe. And what do we see for arguments, though, against this? We see the multiverse. We talked a little bit about that last time, right? We see Krauss's explanation for how parts of it have always been here, yet that's what was responsible for their creation. We looked at that last time. We even see them going to the extremes of saying, we're not really here. This is just part of our mental process. None of this is actually going on. See, you have to go to these extremes in order to try and explain this away. So what are you left with? I think well beyond a reasonable doubt, you are left with that theistic creator that I was talking about. One of the reasons why I love looking at this, though, is because it gives me reassurance. See, when I look out at the universe, knowing everything that has went into it, everything that's within my knowledge of what's went into it, we're still learning stuff constantly, but knowing all the levels of precision that went into it, knowing the size of it, knowing the precision, when I start hitting parts in my life where they're hard, where they're difficult, where I think it's a problem that cannot be solved, if my Creator can do all of this, I don't have to worry about my tiny little problem. When I've been promised salvation and I can spend eternity with the one that has the power to do all of this, all of a sudden the worst problem on earth now becomes doable because I have the promise of being with the Creator. Another kind of cool factor, it has absolutely nothing to do with the fine-tuning. It's just a cool factor. We now are at the point more than ever before where we have the intelligence to know what we're looking for and to build the equipment to see what we're looking at, right? So we are now at the moment where we can see as far as possible. If we would have this wisdom much later than now, we wouldn't be able to see back, though. Remember how I said the universe is expanding? If we wouldn't have this intelligence and the tools that we have been able to build because of the wisdom that God has given us, if we wouldn't have that for a while yet, we would lose a lot of what we're able to see now. But there's another thing. Our location, remember we had talked about the location of our solar system, the location of our galaxy, and what's around us. We are in a very nice point to where we can see. Most other locations, you have something blocking it so that you cannot see. We have got the ability to see out so far and the intelligence to be able to build it that we can actually see God's fingerprints on everything else, right? Last time I had given you some quotes about different things that some astronomers have said, right? It's like seeing the machining marks of God. It's like seeing God's fingerprints on the universe. I hope you see why they say this now, the more that you start looking. Like I said, this is only a fraction of what's out there. So do you guys have any questions about this? I know we covered a lot. And one thing is, I know the camera's going, but if you want to ask a question and you don't want it to be on there, just say so. That's the power of editing. I promise you we'll take it out, okay? Okay. Well, we'll end in prayer here, okay? Lord, I just thank you for this group of people that we can come together and learn more about what you have put around us that allows us to see you, Lord. When we see the creation, when we see everything that you have put around us, and we see how fine-tuned it is, and how everything has to interlock just so in order for us to exist, we can't help but see your majesty, your might, your wisdom. And that is just so reassuring, Lord. We thank you for being able to trust in you. We thank you for being able to know that the biggest problems that we face are so small to you. Lord, I just ask that you keep this in mind every time we look up at the stars at night. Give us this reassurance. Let us see you every time that we learn more about your creation, Lord. In your glorious name we pray. Amen.